It's a wild world out there, isn't it?
Uh-huh.
They're just swimming in data. And these invisible algorithms seem to be increasingly calling the shots in our lives.
Yeah, they really are.
Makes you wonder, how can we really get a grip on what's happening, behind the scenes and make smart decisions when so much is kind of hidden away in code?
That's exactly what we're diving into today. Think of this as your express lane to understanding, maybe.
Oh.
We've pulled together a whole range of recent research and analysis, scientific studies, industry reports, even some legal perspectives, all sort of zeroing in on this really critical issue: bias and fairness in artificial intelligence.
Got it. So our goal today, well, it's really to cut through the confusion around AI bias.
Exactly.
We want to look beyond just the headlines, really try to understand how it plays out, why it's such a tough nut to crack, and, well, why it should concern everyone, whether you're a tech expert or just, going about your day.
Absolutely. It affects us all.
Okay, so let's get into it. Where does this bias in AI actually come from?
Well, our sources point to several key places. A major one is biased training data. That's kind of the starting point.
Right. The data it learns from.
Yeah. If an AI learns from information that doesn't accurately reflect the real world's diversity, or if that info already contains existing societal biases, then those biases will inevitably sort of become part of the AI's decision-making process.
We've seen some pretty clear examples of this, haven't we? The sources mention the Compass system in the U.S.
Oh, yeah, Compass, used for predicting the likelihood of someone reoffending.
And it turned out it was incorrectly identifying black defendants as being at higher risk compared to white defendants. That's pretty bad.
It is. Research definitely confirmed those discrepancies. And another really striking example is Amazon's hiring tool.
I remember hearing about that one.
Yeah, because the data it learned from was mostly from, well, a male-dominated workforce.
Okay.
The AI actually developed a bias against female applicants. It learned the existing pattern.
Wow. It's almost like the AI is just holding up a mirror to the world as it is, warts and all, not necessarily how we'd want it to be.
That's a good way to put it. And what's particularly concerning, as some researchers pointed out, is that people affected by these biased systems, they might not even know. They might not realize they're being treated unfairly.
That's scary. Hidden discrimination.
Precisely. And look, it's not just about underrepresentation in the data either. Sometimes historical biases that are already in the data just get amplified by the AI's algorithm.
Amplified? How so?
Well, the way an algorithm is designed, it might prioritize certain outcomes, maybe speed or efficiency or profit. And doing that can unintentionally lead to unfair outcomes for certain groups, even if that wasn't the goal.
Okay, so the data is one thing, the algorithm's another.
Yeah.
The sources also talk about data gaps and data inequalities. What does that mean exactly?
It's a really fundamental issue. Some analyses stress this lack of comprehensive data that truly includes all segments of the population, especially those who are traditionally underserved or marginalized.
So they're just missing from the picture.
Effectively, yeah. Their absence means these groups are often invisible to AI systems. It's like trying to paint a full picture with only half the colors.
And this isn't just some historical problem, is it? I mean, even major data gathering bodies like the U.S. Census Bureau,
Right.
they face ongoing questions about who gets counted, how categories like race or ethnicity are defined, even like political influence potentially affecting the data collection itself.
Exactly. These are very much current issues. And plus, other research highlights this unequal control over data and the infrastructure that handles it.
Unequal control.
Yeah.
Meaning big companies.
Yeah, often powerful corporations. This control lets them shape what data gets gathered in the first place. And it can even potentially influence our behavior, maybe reinforcing existing inequalities. How so? Influencing behavior. Well, think about the platforms we use. The data they collect shapes the algorithms, which then shape what we see, what we're offered. It can create feedback loops. It's not just about owning the raw data, it's about controlling the flow of information itself.
Okay, wow. So bias can sneak in through the data, through the algorithms, even through who holds the reins on the data pipeline.
All potential entry points.
But then how do we even decide if an AI is fair? It sounds like fairness itself isn't straightforward, like it could mean different things to different people.
You've absolutely hit on a critical point there. One report from the Nuffield Foundation really digs into this. Terms like bias and fairness. they're surprisingly complex, surprisingly ambiguous.
How so?
Well, data that might seem statistically unbiased, maybe had as equal representation of groups, can still reflect and actually perpetuate existing societal biases.
So just having like equal numbers in a data set doesn't automatically mean it's fair in the real world.
Correct, not necessarily. And then we face the challenge of how to actually measure fairness. It's tough.
Right. How do you put a number on it?
Exactly. Different situations might need different yardsticks, different metrics. For example, if you're predicting loan repayment, you might focus on something called equalized odds.
Equalized odds.
Yeah, essentially making sure the AI is equally good or equally bad, maybe at predicting repayment correctly and incorrectly across different groups.
Okay. So try and make sure the error rates are the same for everyone.
Kind of, yeah. Think of it like ensuring the AI is equally good at both correctly identifying who will repay a loan and also incorrectly denying a loan to someone who would have repaid across different demographic groups. It's about balancing different types of errors.
But here's the tricky part I read about. Focusing on one of these fairness metrics can actually make things worse, according to another metric, right?
Precisely. Research has shown these trade-offs very clearly. There's often this tension between, say, group fairness.
Like equal outcomes across groups.
Right. And individual fairness, which is about treating similar individuals similarly, regardless of their group.
Okay.
You could, in theory, achieve perfect individual fairness, but still see huge disparities between group outcomes. And other studies have noted that if you improve fairness for one characteristic, like maybe race, you could unintentionally reduce fairness for another, like gender. It gets complicated fast.
So there's no single magic bullet for fairness.
Definitely not. The core takeaway here is that achieving fairness isn't just checking a box. It involves navigating really difficult choices, often with no easy answers.
It feels like this constant balancing act. And then there's this idea I saw mentioned, the leaderboard illusion. What's that all about?
Yes, that's a really insightful concept. You know how we have these leaderboards now, ranking AI models?
Graham, they're everywhere, tracking performance.
Well, there's a risk these leaderboards could actually be misleading when it comes to judging how good or fair a model really is.
Misleading how?
Well, one issue is something called best-of-n private testing. Developers might test, say, 10 versions of their model privately and only release the one that scored highest on the benchmark, which can obviously make their overall performance seem better than it perhaps really is on average.
So it's like they're taking multiple shots at the target and only showing us the one time they hit the bullseye.
Exactly like that. Another issue is just differences in data access.
Right.
Some developers, usually the bigger players, just have vastly more data to train and test their models on. It's not an even playing field.
So they have an inherent advantage on the leaderboard.
Potentially, yes. And this can lead to models becoming really, really good at acing the specific benchmarks they're tested on.
Okay.
But that doesn't necessarily mean they're better or fairer in a more general real-world sense. It could just be overfitting to the test.
Overfitting, like teaching to the test.
Exactly. And another paper showed that these benchmark results can be surprisingly sensitive to tiny changes.
Like what?
Like just changing the order of the answer choices in a multiple-choice question, or slight variations in how you phrase the prompt you give the AI.
Wow, so a top rank might not be as robust as it looks.
That's the concern. Just because an AI ranks high on one specific leaderboard doesn't automatically mean it's more reliable or fairer across the board in real-world situations.
So what's the alternative? If single leaderboards are potentially flawed?
Well, one idea gaining traction is using benchmark suites.
Suites, like multiple tests.
Exactly, a collection of different tests measuring different aspects of performance and fairness. The thinking is that this might give us a more rounded, more complete picture than relying on just one number from one test.
That makes sense. Get a broader view.
Right.
This all sounds incredibly complex to actually fix. So what are some of the ways researchers are actually trying to address this bias? How do you mitigate it?
Well, broadly speaking, the techniques fall into three main buckets or stages.
Okay.
There's pre-processing. That means trying to fix the data before you even train the AI, adjusting the training data to reduce bias.
Got it. Clean the data first.
Then there's in-processing. This is where you adapt the learning algorithm itself, build fairness constraints into the training process.
Okay, tweak the recipe.
Exactly. And finally, there's post-processing. This happens after the AI is trained. You basically adjust the AI's outputs or predictions to try and make them fairer.
So like overriding the AI's initial answer sometimes.
Sort of, yeah. Adjusting the thresholds or decisions based on fairness goals. There are various ways to do each of these.
And are these methods generally applicable? Like, can you use them on any kind of AI model?
That's a really important goal and an ongoing area of research. Ideally, yes. The methods should work across different types of machine learning models, especially for those complex models where we don't fully understand how they reach their decisions, the so-called black boxes.
Right. You need tools that work even if you can't peek inside.
Precisely. And the good news is there's a growing number of open source toolkits and libraries becoming available.
Oh, really? Like what?
Things like FairLearn, AIF 360, fairness indicators. These provide tools for developers to actually assess and try to reduce unfairness in their models, so the resources are building up.
That's good to hear. Tools are emerging. What about the legal side? Are there rules or regulations trying to prevent this?
Yes, definitely. There are legal frameworks and regulations evolving, particularly in places like the US, the EU, and the UK, aimed at preventing discrimination by these automated decision-making systems, or ADMS. For example, the UK's Equality Act has specific definitions of direct and indirect discrimination. It also talks about things like positive action versus positive discrimination, which are relevant here. And often, systems used in the public sector have an even higher bar. They might be required to actively promote equality, not just avoid discrimination.
So there's legal pressure too.
Yeah.
But doesn't measuring and mitigating bias often require knowing things like people's race or gender? Isn't collecting that kind of data sensitive?
That's a huge challenge, absolutely. To check for bias against certain protected groups, you often need data on those protected characteristics. But collecting, storing, and using that data raises major privacy concerns and ethical questions. It's a real tightrope walk.
Yeah, I could see that. How do you fix bias without potentially violating privacy?
It's a difficult balance. There are techniques being explored, like using proxy variables or statistical methods that don't require direct sensitive data, but it's definitely not straightforward.
Okay. Are there other approaches beyond just tweaking algorithms or data, like bigger picture things?
Well, some sources touch upon ideas like using technology itself to foster more inclusive access, things like developing smart infrastructure designed with equity in mind, or expanding telemedicine and e-learning to reach underserved communities.
So using tech to bridge gaps rather than create them.
That's the idea, using tech proactively for inclusion.
This brings up another point from the Nuffield report. These inherent tensions, these trade-offs between different values when we deploy AI.
Yes, that's a crucial aspect. Implementing AI often forces us to confront conflicting values.
Like what kind of conflicts?
Well, for instance, the push for personalization in services. That can sometimes clash with broader values like solidarity or citizenship. Treating everyone the same versus tailoring things individually.
Okay.
Or think about the drive for quality and efficiency in, say, public services using AI. That might bump up against concerns about privacy or people's control over their own information.
Right. Efficiency versus autonomy.
Exactly. There's also often a tension between short-term benefits, maybe cost savings or speed, and potential long-term societal values or consequences. And perhaps most critically, the costs and benefits of these AI systems are often distributed unequally across different social groups. Some people benefit more, some might bear more risks or costs.
So who wins and who loses?
That's often the underlying question. And resolving these trade-offs, these tensions, it's not something technologists can just decide on their own.
Right, it needs broader input.
Absolutely. It really requires engaging with everyone involved, all the stakeholders, including the general public. Using methods like public dialogue or exploring different future scenarios to understand the potential impacts.
So it's a societal conversation, really.
It has to be.
Okay, let's connect this back. Thinking about the real-world impact. Why should all of this, the bias, the fairness metrics, the trade-offs, why should it matter to you, our listener, especially if you're not, building AI systems yourself?
Well, because these biased AI systems are increasingly woven into the fabric of our everyday lives, whether we realize it or not.
How so? Give me some examples.
They can influence really crucial decisions, like whether you get approved for a loan or a mortgage, what job advertisements you see online, or if your resume even gets seen by a human recruiter.
Right.
It can affect the quality of healthcare you might receive, diagnostic tools. Even the news and information you encounter online is shaped by algorithms that might have biases.
So it's touching almost everything.
Pretty much. You might not always see it happening directly, but these systems are constantly shaping opportunities and outcomes behind the scenes. It really boils down to fundamental issues of fairness and equity in our increasingly digital world.
So understanding this stuff isn't just for techies. It helps all of us become more aware, more informed about the forces shaping our world.
Exactly. Developing a critical understanding of how these systems work and, importantly, where they might fall short or have hidden biases, it empowers you.
Empowers you how?
It helps you be a more informed consumer of technology, for one, but also potentially a more effective advocate for fairer technologies. It's about understanding the currents that are increasingly directing your life and the lives of others.
Okay, so wrapping things up from this deep dive, it seems clear that AI bias is, well, it's a really intricate issue.
Definitely not simple.
It has roots deep in our data, in the algorithms themselves, and even in how we try to define and measure something as slippery as fairness.
Right. The definitions matter hugely.
And tackling it is a significant ongoing challenge. Not just a technical one, but a societal one, too. And it has very real, tangible consequences for people.
That's a great summary. And it leaves us, and you, the listener, with a pretty big question to think about, doesn't it?
Which is?
Given how much we're coming to rely on AI, how can we, all of us as individuals and as a society, work together? How do we ensure these incredibly powerful technologies are developed and used in a way that genuinely promotes equity and justice for everyone, instead of just accidentally, or maybe not so accidentally, reinforcing the inequalities that already exist?
Yeah. How do we build fair AI, not just functional AI?
Exactly. And it's a question that touches on the responsibilities of, well, everyone. The developers creating the systems, the organizations deploying them, and those of us interacting with them every day.
Definitely something to mull over. If you are interested in exploring this topic more, we really encourage you to check out some of the research and analysis we've discussed today.
Yeah, there's a lot more detail and nuance in those sources we drew from. Plenty to dig into if you want to go deeper.